And now for the other half of the test, which is we have the computer with the USB to serial cable. And again, we're looking at the ground and transmission line. And when I press a key, we are sending some serial codes again, depending on which key I press. And this is very different. This is definitely, when I'm not sending anything, idle is at 0 volts. So that is definitely not RS-232, but it's also not the UART that the microcontroller expects. Otherwise, it would be idle would be at 5 volts. And when we press the key, the sort of logical true becomes 5 volts. So to make things easier to be able to connect things to the receiving and transmission lines, I'm going to solder another row of pins right there. So that way we'll be able to bypass some of the amplification and resistors that deal with the RS-232 and just go straight there. So I noticed something else that is a little bit more worrisome, which is I think the signals being sent by the computer along the USB to serial port were slower than the ones generated by the CB2. So let's run some tests. I have here the computer hooked up to the CB2. The CB2 is not even plugged in. I've just hooked up in here because it's a convenient way for me to hook up the oscilloscope, so I don't have any bridges right there, and I have the probe hooked up to the transmit pin and then to ground. And then in the computer, I have hyperterminal running configured at 2400 baud, just like we had the CB2 earlier. So when I send a character like W, like we were using earlier for a test, yeah, that seems really slow. Very, very slow. This is the signal coming from the CB2. And let's assume the first pulse is 1 bit. The scale is 1 grid is 800 microseconds. So that looks a little bit more than half, so maybe 500 microseconds. So 1 divided by 500 microseconds, so the inverse of that gives us 2000 bits per second, which is approximately the 2400 BPS that we were expecting. And now the signal coming out of the PC, if we take the first pulse to also be 1 bit, we notice the scale is very different. The scale is 2 milliseconds per square, so that's a little bit less than 3 milliseconds, let's say 2.5 milliseconds. So the inverse of that is only 400 BPS. What a difference. So what happens if I change it to a different speed? So if I set it to 4800. Okay, it's now configured to 4800, and yeah, that is not just twice as fast. That is way faster. That seems about right. That seems faster than what we're seeing on the CB2, but this is like 10 times faster than what supposedly was 2400. And what about 1200? Okay, there we go with 1200. And yeah, that's very slow. That is not 4 times slower. Ironically, that seems maybe faster than the 2400 that we're seeing earlier. But yeah, that seems wrong. Also, okay, this is bizarre. I'm pressing the same key. I'm pressing W repeatedly, and it's sending different pulses. That cannot be good. Sometimes it sends a short pulse to start with, sometimes it's a wider one, sometimes it's a third one. So this is really making me think that the electronics inside this USB to serial connector are just not working correctly. And maybe this is okay at 4800. It looked okay on the oscilloscope. Unfortunately, the CB2 only seems to run at 1200 and 2400. Now, there's some other options in the menu, so maybe we can explore that and see if we can make something work. In the configuration page of the CB2, we can change the serial speed. And it looks like we can change from 2400 to 9600, but then there's a 1 that changes into a 2. That means it's the second port. It's not the normal port that we're using. And same thing with the 38.4K, and then it goes back to 1200. So in port 1, we're out of luck and we can only use 1200 or 2400. I actually managed to get another USB to serial cable in just in the nick of time for the video. Let's give it a try and see if that's a problem with all of them or if this one works correctly. So I've hooked it up to the CB2, but again, it's just not connected. I'm just measuring the signals coming out of the transmit line. And okay, right away, this looks very different. This is a true RS-232. This is, I'm not transmitting anything, and the signal, it's right sitting at -6. And when I press a key, there you go. It goes to +6. So it has the wide voltage range you would come to expect. And it's getting all the way to +6 over there. So, and it's positive with the logical one. So that looks really good. Let's connect it and see if it just works right away. Okay, and let's see if I get, yeah, there you go. Great, and from here, yep, they show up great on the other terminal. So this is the way it should have worked from the beginning, and we just had a defective cable, but okay, that's good. That's much simpler. Okay, so I'm gonna go to one of the slots where I want this. This is where I was doing my test earlier. Let's do a receive. Let's see, so control F3. Right, receive program. Yes. Okay, now it's waiting. And I'm just gonna paste it straight in the terminal. There we go. There we go. Did that work? It looks okay. Let's run it. Save it first. Save, yes. And let's run it. There we go. Oh, I don't know the keys. Oh, there you go. Awesome.